Hi everyone, it's already midday. Half of the conference has passed already, so I hope you've been learning a lot and been watching some interesting talks and that you're eager to learn about databases with me. So I welcome you all to my talk, to SQL or NoSQL. My name is Victoria and I'm here because I love talking about databases. And all of these little pictures are not because I like animals and I wanted to make the slides a little bit nicer. Those are all the types of databases that I worked with in the last 10 years. So let's start. What is a database, you may wonder? If you come from a computer science background, this is how you learn it. You open a book and you read something like a database is a collection of persistent data that is used by the application system of some given enterprise. But what does it mean? It seems to me that it's just a lot of fancy words, and it may be. What does that mean in our day-to-day life? So think a little bit about what you do every day. You get your phone and you open an app. Let's say you open an app to send messages. Those messages will be stored in a database. And then you open an app to listen to some music. That music will be stored in a database. And then maybe you start working and you open an Excel file. All that data is a database as well. Or maybe you use an ERP system. That ERP system is using a database behind. So basically a database, you can think about a database as anything a system where you can store a lot of different data. But not all databases are the same. So it's not like if we open a bank account and then our moves in our bank account will be stored in a database, but it won't be the same type database that the app we use to listen to music stores the music, or that the ERP system stores the data from a company. And that's when we talk about types of databases. And here's when the thing gets a little bit tricky. Because if you try to Google this, a lot of things start appear, especially Wikipedia first. You'll find something like this that it looks very scary. And there's a lot of databases, and they're all kind of the same, but at the same different. And then you find something like this. Very nice, a little bit shorter, but still. What is it? A personal database? It cannot be a NoSQL database, and it cannot be operational. And then you have something like this. So these are all brands, kind of. These are all companies. So then let's try again. What are the types of databases? And I'm going to define relational and non-relational. And when we talk about relational, we talk a little bit about SQL. We can also read some things like RD, VMS, which sounds a little bit like a tongue twister. And we can think about a picture similar to this one. So a lot of tables united, somehow connected. And when we talk about non-relational databases, we talk a little bit about NoSQL, and we can think about something like this. But then we'll see that it can be something similar to documents, but it can be also other things. So let's start with relational databases and SQL. What are relational databases? They were created in the 60s to store structured data. They basically had a set of tables that had columns and rows. So similar to Excel, you can think of each spreadsheet as being a table and then the whole Excel file as a database. And between those tables, normally they have relations. For example, if we have a table where we would have a name, a city, and an age, we would have a relation between tables using the same name with a different one where we would store the payments that these users had. So the relation here between tables would be the name. And there we could know by this relation which payments were made by a certain user and the data that the user has. So, what is SQL? SQL means a structured query language, and it appears in the 70s. As you can see here, there's already a lapse of some years. Why did SQL appear? Because when all these databases solutions appeared, there were a lot of confusion. Each database that was created by some vendor had their own way to use the data, their own way to access and transform the data. So then SQL came. Because you have to also think that we are talking about the 60s. In the 60s, it wasn't that easy to get the knowledge. So it was very, very hard for the companies, let's say, they wanted to get an employee that already knew their technology, the technology that they were using to manage their databases. But it's not so easy because everyone were using different types of databases, meaning different types of extracting and manipulating this data. And the knowledge came from books. There was no internet like we do today. In 5 minutes, we can just easily learn how to write it. So SQL came. SQL appeared as a solution to this. And it was standardized by ANSI, which means that there were a lot of vendors, but they were all using the same standard. So a person that was using one type of database could easily change jobs and start using a different database from a different vendor, but still he or she would know how to use it. There are small variations according vendors, but the general logic is the same, and the basic words that are being used are the same. So here, for example, I have 4 different types of vendors. The first one is SQL Server, and in this query, what I'm trying to do is trying to get the first 10 rows from a table. So if you see here, I have to select top 10 from that field that I want from the table. So select top 10 will give me the 10 rows, and then the from will define which table I'm taking the data from. In Oracle, we can also see that there's a select, there's a from, and there's a where. So those are the words that we see that are repeating in every vendor. But here, instead of having a top 10, I will use a row num minus or equal to 10. For MySQL, I would use limit 10, which is actually that is pure ANSI. And then in Postgres, I could use fetch first 10 row only. I wanted to show this one to see the variations, but of course in Postgres, you could also use limit 10, for example. Okay, let's see what is NoSQL. NoSQL appeared in the 90s, but it only became very popular in around 2010. And the reason for that is because there was the web became very popular. And with the web, when we became widestream, a lot of data started being accumulated. And also there was a big need to have this data available all across the globe. So we needed to have a high concurrency because we could have people using our website from China to Argentina and Canada at the same time. And that data needed to be available for all of them. And relational databases presented an issue in there. So that's when NoSQL became a big thing. It depends mostly on the vendor, but not in the same way than SQL. In SQL, they all have to use and respect the ANSI, what ANSI establishes for SQL. But then on top of that, each vendor can change or add a little bit, like some things on the wordings, for example, or maybe add more functions. But in NoSQL, it depends entirely on the vendor. Each vendor does basically what they want. And we have different subtypes. Here are some of the most famous non-SQL databases, being Mongodb probably the most famous one. And here's a little joke about the type of NoSQL databases that we'll find. These are some of the types that we'll find. Key value, big tables, documents, graph, and there's also SQL as well. And this is an explanation, a little bit more detail about each type of NoSQL. On documents, is as it says, as the name says, you can imagine your data is stored in documents. And they will look something like we see over there, kind of like a JSON file, if you know. And the good thing about this is that there's no structure here. Each file can have the structure you want. So if you want to store a lot of things about something in one document, you can. And if you want to store only one or two things in another document, you can as well. You don't need to follow a structure. You don't need to also declare the same amount of data if you want. So that's the idea of the documents. Here again, MongoDB, the most known NoSQL database, uses document. There's also graph. A graph is like this, like we see. We define a node, and then there are edges, which would be the connections between the data. This is something that is becoming very popular lately, these last years. Then we have key value, where we would have a key and a value assigned. Then there's also key order value, which would be the same than key value, but it would follow a certain order that we define. And there's white column. White column is a table. It looks very similar. If we look like this at this picture, it looks very similar to a relational table, but in here we don't have to follow the structure. We can put anything. So in a table, one would think that you always have the same amount of columns and then you would only add rows. But in a white column table, you don't need to follow the same structure of columns every time. Okay, so what is the difference? First of all, let's see at the market. SQL is still dominating the market nowadays. So 60% of the databases that are being used are SQL. Although it's an old technology and NoSQL, when it appeared, it became super popular and there were a lot of bad publicity against SQL, and it seemed for a while that SQL was dying. Still is the most used in today. If we look at the top open source databases, still we have SQL in the dominating one, because we have MySQL, we have Postgres, and in the third place we had Mongo. And if we look at the commercial databases that are being used, Oracle is the biggest one out of the three. And these are the three. Even though we have more SQL types of databases, these are the three more used in the market nowadays. Okay, so let's talk a little bit about the differences. For the relational databases, we require a defined and structured schema. So we must say, before we store the data, we have to say how the tables are going to be defined, what are the columns going to be, what type of data we are going to store. So I have to prepare everything, and then I'm going to store the data. This, of course, needs a lot of preparation. You need to really know what you're going to store and why you need this database. How are you going to use it? There's a huge community supporting it. I mean, it's been since the 70s, so there's a lot of people that are active in forums. There's a lot of documentation going on. There's a lot of books. So basically, you'll never be alone when you have an issue with SQL. It needs more managed scalability. We'll talk a little bit about this later, but it is more difficult if you want to have more compute power. Let's say if you need more users, if you need more users accessing to your database, if you need to store more data, then it's going to be more expensive. SQL, it uses SQL. Relational databases, they use SQL, which means those are transferable skills. As I said before, if I know how to learn SQL, how to write SQL, then I can just simply move from shop to shop, from database to database. As long as it's relational, I'm going to know how to use it, because it's only small wordings, but the whole logic is completely the same. The same is for the companies. If they're using a relational database, it's going to be very easy to find people that's going to have those skills. It's very easy to learn as well. It has a lot of reporting tools. The most famous reporting tools, the best reporting tools, are used with SQL. It can offer some performance problems for big data, and it supports ACID. For NoSQL, on the other side, we have they allow the persistence of any data in the document. So a little bit what I said before for SQL, that you need to know what you're going to store, how are you going to store it, basically what type of data. For a document, you don't really need it. You can just say, okay, when the data comes, I'll figure it out. It has a small community. Also because I wouldn't say it's a small community in general. There's a big community, but it depends a lot on the vendor, right? So then if you have an issue, it's not like if you have an issue with SQL, anyone that uses any type of vendor can help you. But if you have an issue with NoSQL, you only depend on the people that is using the same vendor as you are. And that is, of course, next to the SQL community, very, very small. It's easier to escalate. That was also one of the reasons why it became so popular with the web. It has no structured query language. Every vendor will use a different type of languages, although many of them nowadays, they do support SQL because they know that that's, of course, makes things way easier. That's not something that every NoSQL database has. It has few reporting tools, and it's very difficult to standardize, which means that when you get your database and your reporting tool, you're kind of like stuck with that. It's going to be very easy to change one and not the other. They have excellent performance on big data. They have a limited support for joins. And the data is denormalized, requiring mass updates. Which means, let's say, if you don't know what you were storing, let's say that in each document I'm storing, I don't know, something about my family, and then in one document I store some data about my father, and I put everything I want to store about my father, and in other I put everything I want to store about my sister. Since I haven't put the same kind of data like I would do in SQL, because I would have defined columns beforehand, it's very hard to do updates afterwards. Let's do a little bit of a break here from databases, and let's talk about ACID properties, because it's very important to understand why this is an advantage in SQL on top of the NoSQL databases. So ACID basically means it's A for atomicity, which means that each transaction is either all or nothing. So if I do a transaction, it has to be complete. Consistency means that the data will have integrity, which means that each transaction will start only if it can warrant exact and consistent data at the end of the transaction. If the system knows beforehand that cannot be assured, then the transaction won't happen, will fail before starting. We won't stop at the middle of the transaction. Isolation means that every transaction will be independent from the other. They cannot be executed together at the same time. Each transaction will be executed on their own. And the D is for durability, which means that every change that a transaction will do will be persistent. Let's see a little bit about how it looks like a relational database and a non-relational database. Here we have an article. On the first side, in the red rectangle, we have what would be the relational database approach. Basically, we would have, for example, for the article itself, we would have an article table, and then we would have an author table. And they'll have a link, right? Each author can have one or more articles linked to it in the article table. On the other side, for the comments, we would have something similar. We would have a comment table, and then we would have a reader table as well. But in a document-based database, so in a NoSQL database, we would have something like this. We would have a file where we would store everything related to this article. And of course here, if you see, for example, that we have the username and the join date and the comment ID, we could have more stuff on top of that. From the article, we could have more stuff as well, but we could have another article that has no data regarding those topics. And that's what is interesting about the relational databases. Here we can see a difference in how it looks, trying to select the first 10 rows of a table in the different databases. So we already seen the SQL server, which would be SQL in general. In Mongodb, something similar to JSON, if you know what JSON is. And as you see, it's a little bit more complicated than SQL. And Neo4j, they use this language that they call Cypher, which is quite similar to SQL. So the idea in general is pretty similar to SQL. They base it on that. Here is how it looks, a relational database versus a MongoDB. This is from MongoDB's webpage, so it's not super fair with relational databases, since in one side we can see a million tables and in the other one we can only see one document, where to store the same amount of data we would have a million documents probably. But yes, this is super clear on how one looks and the other. Here, it's how it looks. SQL versus Couchbase. Couchbase also has a language that's called N1QL, which is based on SQL. And the idea is that it's the same as SQL. And if you know SQL, you could move to NYQL easily and you wouldn't have to learn anything new. So SQL, we already know how it is. It's select the field names from the table name, and the table name would look something like this, a table with a name and an author. In Couchbase, the query is the same because it's based on SQL, but in the database, the data will be stored like this, not like a table. It will be based like a document. Okay, so but when do I choose relational databases and where do I choose a NoSQL database? I would choose a relational database if I have a medium to large scale databases. If I have fairly low concurrency, if ACID is a must, if the data is highly correlated, if there's a big need of complex reporting, and if there's vertical scaling needed. So basically, let's summarize. When would I use a relational database? If I know how my data looks like. If I know that my data is going to be a certain way and won't change. It's not like we won't change. We can, of course, change the structure. We can, of course, change the data. But we don't need to have this freedom that we are always changing things. We kind of like have an idea how data will look like. So for example, in accounting, it's fairly simple. Once you set up the structure, you won't need much more than that. In those cases, relational databases are great. They're going to work fine. they're going to be the right solution in there. Also, if you're in accounting, you probably need a lot of reporting. If you're in controlling, for example, for finance departments, they would need a relational databases. That's why ERPs work with relational databases. ACID is a must. If we remember, if we have a bank, for example, we need to have ACID, because we cannot have transactions that are being cut in the middle of a money extraction, for example. We need to know that if the money extraction starts, it's because it's going to be able to complete, meaning that we have enough money in the account to do it. We have the money in the ATM to provide it to the customer, and the whole process is going to finish, for example. Otherwise, we could have people taking money without having enough on the other side, or discounting money from someone's account without having the money in the ATM to provide it. So ACID is a must in those kind of databases. And then on the other side, we have NoSQL. It is a very good option when there's a larger scale database. When we need high concurrency, a lot of people using the same database all the time. The same with the web that I was mentioning. A lot of people all over the world trying to go and get the same data from the same database. ACID can be relegated. In some cases, it's not so bad if a transaction fails in the middle of it, because on the other hand, we are gaining so much on what is important for our business, which would be, for example, that everyone can access to a database at the same time instead of having to wait for it. We don't need a static scheme, and we want the freedoms in changes during development. So if I know that I have a website where I'm asking a lot of people to send me data, and the data that they send me is whatever they want, then I need this, because I don't know what it's going to come. So I need to have this freedom that whatever comes, it's going to be stored. And that's what NoSQL provides. And then horizontal scaling is needed. And I'm going to talk a little bit about what is horizontal and what is vertical. So Vertigo Scaling is also known as a scale up. And basically when we want more from our database, so we want to have more users accessing because it's slow, it's not enough. We want to have more data. We need to add more resources. So we have this big, huge database and we have this in a server, and we need to add more RAM, more CPU, more disk. And on the other side, the NoSQL follows a little bit more the scale out, which is horizontal scaling. And in that case, we're going to have more hardware. So instead of having a computer like a supercomputer that's of course very expensive to get, we're going to have multiple ones. What are the common uses for each type of database? In relational databases, we're going to find them in accounting, in finance, as I mentioned before, in banking systems, in transaction management systems, because transactions are a little bit like I said about accounting. They're kind of like the same. They're always going to, if I buy something, it's always going to be the same, the transaction that I'm going to get. NoSQL is mostly used in mobile apps, in real-time analytics, because it's a lot of data and it's to be processed very fast, in content management, personalizations, and IoT apps. Okay, let's see some use cases. The first one is about eBay, from Oracle to Couchbase. So they moved from SQL to NoSQL, basically. They had Oracle, but it wasn't enough for eBay. The licenses, the hardware, all of this scaling I was talking about, and the support as well, they were making Oracle being very, very expensive for eBay. On top of that, all the ACID features, because of course ACID gives you a lot of security on one side, but on the other side, there's a lot of things that have to be checked before you start a transaction. all of this was impacting on the performance of eBay site. And eBay being an e-commerce, they cannot have a website that's not performant. They need everything to be available right now. Otherwise, the person will just switch to another website, right? And will go to another e-commerce. So that was crucial for eBay. And then they didn't have native sharding and replication features. So eBay being everywhere in the world, they really, really needed this availability everywhere. They needed this to be fast and accessible from everywhere in the world. So then they decided to move to Couchbase. They implemented Couchbase in 2014. The good thing about Couchbase, for eBay at least, is that they have linear scalability and high read and write for the application, which means that it was super responsive. And the users, like, although they were having more and more users every time, it was still super responsive, and they could easily have everything as soon as they were entering into the website. There were no delays here because of the database. Couchbase had location-aware low latency querying, which means the location-aware low latency means that they're going to make it easier for queries all around the world by responding in a location-aware way, which this is going to, of course, make it easier and faster for the user, for the end user, consulting the data from the database. And they had a flexible schema, and this increases the developer agility. They don't need to do a fixing if they want to change something, because it's a flexible schema. They can just add it in the document. They can just put that data in. And the key features here is that Couchbase has N1QL, which is basically SQL, but they still having the flexibility of a JSON file. They had in-memory databases, so kind of like cache, what that was making faster every response, and they had cross data center replication. Let's see a use case for a NoSQL database. Flexcoin and Poloniex, from MongoDB to nothing. Okay, so NoSQL is very good, and it checks a lot of boxes. And it's an amazing solution for a lot of things, but if it's not correctly implemented, it can be very bad. So Flexcoin used to be a site for Bitcoin exchange. In March 2014, they had an issue because there was a flaw in their code, and this flaw allowed the users to transfer between accounts without having these asset properties that I mentioned before. So then a person used this flaw in the code that sent 1,000 of simultaneous requests until at a certain point the accounts didn't have money to send anymore, bitcoins to send anymore, so they were overdrawn before the balances were updated. So they were able to move bitcoins that they didn't have in one account to the other. So of course this was very bad for the website, and they went broke. And then Poloniex is basically the same story. It was it was also a Bitcoin exchange website. It was attacked also in 2014 in March. And it was something similar. It was a vulnerability in the code, but for the withdrawals. So then a hacker placed several withdrawals at the same time, and then a lot of them started being successful, even though there weren't real funds to cover. So they took a lot of money that didn't exist on the other side, basically. So what's the conclusion here? Understand your data and your business needs. It doesn't mean that if you choose always SQL, it will be super good. It can also fail with SQL. It doesn't mean that if you choose NoSQL, it's going to be great. And it doesn't mean that NoSQL is better than SQL. It's like the new thing. And it doesn't mean that SQL has always been there and will always be just because NoSQL is failing at certain things. The nice thing about here about the databases in SQL and SQL is that this competition also makes things better. For example, the case that we saw from eBay, they later implemented a lot of things from Couchbase. They learned from their mistake. And the same with SQL. A lot of things that every vendor adds, functions that they add to SQL on their own, later on, they're being added to the ANSI standard, which means that every other database will have it as well. So yeah, it's very important. In conclusion, it's very important to understand what we need, understand what the business needs, what kind of data are we going to handle, what we want to get out of the databases. And only when we know that, we can choose what type of database we want. And lastly, but not least, sometimes all the needs that your business has are not data compatible. And in that case, there's this concept that is called Polyglot Persistence, which means having more than one type of databases. And as we can see, having one or two types of databases is the most common option. So I hope you enjoyed the talk. I hope you learned something. And yeah, I'll be answering questions probably in the chat. If you want, you can contact me. I'm going to upload my slides on my GitHub. And I hope you keep enjoying the rest of the conference.